Hi students, we're now looking at notes section 2.2, domain and range. The domain of an equation is the set of all x's that we can plug into the equation and get back a real number for y. And the range of an equation is the set of all y values that we can ever get out of the equation. Now, when I look at some graphs of functions, I can also tell the domain and range by confirming all the x and y values. So looking at this first function, I need to plot the ordered pairs. So remember, -3 is going to be on -1, 2, 3, and then -1 here, because this is the x-axis and this is the y-axis. Then I go to +4 and -2. 1, 2, 3, 4. And I'm at -2, 1, 2. Then I'm at +1 for x and +1 for y. And then at -3 for x and +2 for y. So this is a non-function because I have the x value that repeats. And you may remember that from yesterday's notes. Now, if I'm listing the domain of this function, it's all the x values. So the x values were -3, 4, +1, and then -3 again, but I've already listed that. And I write it with this cute set notation when I'm doing just a list. The range would be all the y values, and I'm going to use that same notation, that curly Q, and it's going to be -1, -2, +1, and +2. Since all the range values were different, I list all 4 of them. On this next non-function, right, it fails the vertical line test. I'm still going to list the domain and range. So I look at the domain. The first x value, when I'm reading it from left to right this way, is -1. And then the last x value is +5. So we start at -1, we stop at +5. And its x is all the numbers in between those, including -1 and 5. We also can write this with brackets, saying -1, 5. And this means the same thing as this. I read this as x is between -1 and +5. Next, I'm going to do the same thing with the y values, and I'm going to start by going up, and I'm starting here because I can tell that this is where the lowest y value will be. So here's the first y value at -3, less than or equal to y, less than or equal to, and it's all these values, and we stop at +3. And so I can write the y values in the range the same way with the brackets, using the hard bracket on -3, 3 with a hard bracket. And so we use those brackets to indicate equal to. So, for example, a closed circle. Let's look at our next function's domain, a non-function's domain and range. So this one fails the vertical line test, but it still has a domain and range. And so again, I'm going to read the domain from left to right. So I start right here because I can tell that's the part that faces the furthest out. And this is the spot. So that's -4, x. And then x keeps on going. It looks like it's going to keep going forever. And this is going towards positive infinity. Very interesting. So when I go to write that in my bracket notation, I start with the hard bracket and -4. But then notice how I put less than infinity. We're never equal to infinity because of how infinity works. It goes on forever. So watch what I do with my notation. On infinity, we're always going to put a parentheses, or what I'm calling a soft bracket. That's the way I'll differentiate the brackets. Hard bracket for the right angles, and soft bracket for the curves. Now let's look at it for the range. So these arrows are still here, meaning when I start at the bottom, I'm already down here at the very bottom. It's pointing at an angle down, and so it is going to go all the way down to negative infinity. And again, I do the less than, y, and then at this arrow, it appears that it's pointing up, and I think it will keep on going up forever. And so I say positive infinity. So just like before, when I use the soft bracket on infinity, I'm going to use the soft bracket on negative infinity and the soft bracket on positive infinity when I'm talking about the range of this function. Because if you imagine it's going to continue to get wider and wider and wider and wider and wider, if it was to go on forever, and we always just assume that it will. So what's special about infinity, again, is that we use the soft bracket or the parentheses. Okay, you can try the domain on range on this one. I have x's between -1 and +2, and that y is between -1 and +3. How do I write that with bracket notation? And this is what I write. So remember, the x values are the domain, the y values are the range. Those are pretty fun. Now these are all examples of function. They pass the vertical line test, which is it only hits the vertical line in one place. So when I go to graph these, I've got -4, 5. 1, 2, 3, 4, 5. +3, 5. 1, 2, 3, 4, 5. 0 and 5. -2 and -6, -5 and -6. So every x value is different. So that means it's a function. If I take my vertical line, it only hits each of these at one spot. Whereas when we had our other ordered pair, look, it hit my vertical line at 2 spots, meaning it's not a function. So this one is a function because it's the vertical line or the x values that can't repeat to be a function. Now the domain and range are just the same as before. In this case, the domain, we use the set notation because it's a list. Say -4, 3, 0, -2, -5. It would be nice to put those in numerical order. So then I'll start with instead -5, -4, -2, 0, and +3. Let's list the range in numerical order too. -6 and +5. That's it. There weren't a lot of range values. Okay, let's get some more practice with domain and range for this function. So from A to B, the first x value is at -5. And the last x value is at -3, which we write with hard brackets as well. The range of this function starts at -4 and stops at +3. So it starts at -4, stops at +3, and we use hard brackets because it's not infinity. Looking at this function, when I look at the domain, oh, these arrows are pointing, so I think it's going to keep getting wider and wider and wider and wider. which means this domain goes from negative infinity until positive infinity, which with brackets is soft bracket, soft bracket. But the y values have this maximum point at 4, where it doesn't get any taller than that. And so that starts at negative infinity. It's definitely pointing down. And then we have y, and then it goes to the top value. We're definitely there at 4. So we write our range with the brackets as negative infinity, then 4, but with the hard bracket. Really cool. And then this last function is a line, and I can tell it's going to continue to get wider. So it's going to have negative infinity to positive infinity for x. And the same thing for y. It's going to keep going all the way up, very clearly goes all the way up and all the way down. Up to positive infinity, down to negative infinity. So when we have a domain and range like this, we can also say all real numbers. It's another way of saying the same thing. From negative infinity to positive infinity includes all the numbers, and so that's just another way of saying it. Another way we might be asked to find the domain and range is if we're given values for x. And so remember, we plug those in to f, g, and h by plugging them in as the x value. So I would do 1/2 times 0 plus 5. Then I do 1/2 times 3 plus 5. And then I do 1/2 times 7 plus 5. And I do 1/2 times -8 plus 5. So this is the work that I do, and I get out my ordered pairs. This would be 0 plus 5, 5. This is 1.5 plus 5, which is 6.5. Half of 7 is 3.5 plus 5, which is 8.5. And then half of 8 is 4, but it was negative, so -4 plus 5. We actually subtract and get 1. So the range in this case would be 5, 6.5, 8.5, and 1. And I didn't list them in numerical order, but I did list all the answers, so that should be good enough. We'll do the same thing with G. And I want you to try it on G. Cool, so you can see I plugged in the numbers and then these were my answers. If you need to pause to look at my work, you can do that now. And then here's C. Let's do these ones together. I plug in 0 squared plus 2, which is 2. Then I plug in 3 squared plus 2, so I get 9 plus 2, which is 11. Then I plug in 7 squared plus 2, I get 49 plus 2, which is 51. Then the last one is -8 being squared plus 2. So that's going to be positive 64 plus 2, which is 66. We'll list our numbers as a set because it's just a list of numbers. We only need to use the inequality when all the numbers are filled in. Great. Now we have one more set of problems to do, and these ones are find the domain, which means find x if these are the y values. So watch how I do that. I do 0 equals 1/2 x plus 5. And now I'm going to go solve for x. So to solve this one for x, I would subtract 5. Then I have -5 equals 1/2 x. So x times half, that's a fraction, so I times by the fraction upside down, or the reciprocal. And I get x equals -10.